Hello, everyone. Welcome to our Caire webinar today. We are very honored to have Professor Rada Mihalcea to be our speaker today. And her topic is going to be very, very interesting. It's like a mystery still. And it's very, very interesting in NLP. It's called moving away from one-size-fits-all natural language processes. So what is one-size-fits-all and how do we move away? I'm very intrigued. So Professor Rada Mihalcea is a dear friend that I've known since the early 2000s, when she was a young rising star in the field. She is now the established star. And she's currently the president of the Association for Computational Linguistics. It's our professional association in the field of NLP. She's the recipient of a Presidential Early Career Award for Scientists and Engineers, awarded by President Obama. So you met Obama, right? So envious. And an ACM fellow and a AAAI fellow. In 2013, she was made an honorary citizen of her hometown. I don't know how to pronounce this. Cluj-Napoca? How do you
pronounce? Well, A+, great pronunciation.
In Romania. And she's currently the Janice Jenkins Collegiate Professor of Computer Science and Engineering at the University of Michigan and the Director of the Michigan Artificial Intelligence Lab. Her research interests are in computational linguistics with a focus on lexical semantics, multilingual natural language processing, and computational social sciences. She's also very well known for her work on graphical models, right? I think we collaborate a little bit on semantics, semantic parsing a while back. So let's welcome Professor Mihalcea, and I will stop sharing, and Rada, please. Thank you. And and the audience are free to ask questions, right, in the chat, and you can also ask questions in Q&A after the session. So we have about an hour of lecture and then half an hour of Q&A if you want, or we can be more interactive. Right. Thank you, Rada.
Well, thank you for the introduction. And just 1 second, so I share my screen. All right. Thanks, Pascal, for the introduction. And it's really a great pleasure to be doing this virtual visit. As Pascal mentioned, we go way, way back. And I've been admiring her work even before we met. And then I was excited to have this opportunity to have a lot of very rich exchanges over many years and over many different topics in NLP. And I know there is a lot of very exciting work happening at your institute. And so I'm really pleased to be here today. We're here, of course, it's changed meaning over time. It means different things to different people, but at least be in the same virtual room and be able to interact. And like Pascal said, I encourage you to ask questions, ask for clarifications. I may be asking a couple of questions throughout just to hear your perception. So what I want to talk about today is research that we've been doing for a few years now in my research group at Michigan, which really is trying to move away from this one-size-fits-all natural language processing. And just by means of introduction, and mostly as a reminder, which about something that you all know, is that in general, what we see in the world is that those that are most affected by adversarial events are the minorities. And the COVID pandemic is a good example for that, at least in the United States. What we've seen is that the minorities, like African Americans or Hispanics, have been more affected by the pandemic. And that's generally true, that in case of these more exceptional events, the minorities are the ones that are most affected. And yet somehow in natural language processing, we act as if language is sheltered. And so if we just build one model, it would work equally well for everyone. Now, it turns out that that's generally not the case. And another example, just to illustrate, which I ran into recently, and again in the context of the COVID pandemic, is conversations that I had with people from the city of Detroit, where they told me about this new problem they ran into, which is with parents in Detroit doing homeschooling, which is something that happened to many, which ran into a lot of IT problems. So for instance, the laptops they got for their child didn't work, or they couldn't connect to Wi-Fi, or certain application they couldn't open, and so forth. So the city of Detroit found itself overwhelmed with a lot of questions around IT, which they had somehow to handle and answer. Now, this is something that could be very nicely handled by a question answering system, because there is really just a set of questions that the parents ask. So there is a fairly restricted set of questions. And you'd say, well, question answering is fairly advanced. We can use a system that's out there. We train it maybe on some of the data that's being recorded. And then here we have a solution for this particular setting. Now, it turns out that it doesn't work. And the reason it doesn't work is because a lot of the people in Detroit use the Detroit slang. And so it's English, but it's English with certain words and vocabulary on which, if we were to take a question answering system, we'll get pretty poor performance. So this is mostly to say that a lot of what we do in NLP currently follows this one-size-fits-all mechanism where we build language model. We do a lot of tools like part-of-speech tagging, syntactic parsers, and so forth, assuming that once we have it, say we handle English, then it will work for everyone. It turns out that that's actually not the case, and there are different demographic groups on which we get different performance. So what I want to build as an argument in this seminar is that we would benefit from taking a step back and realizing that there is more to language than just words. So what we generally do in computational linguistics, and I know, like I said, there is a lot of exciting work that's happening worldwide, and I know a lot of cool work that's also coming out from students who are here in the audience. There has been a lot of advances that were made in, for instance, creating word representations, or maybe representing phrases or relations between words, or interpreting entire sentences, finding word dependencies, and so forth. Now, what I think we should do as a big next step in NLP is to acknowledge that what we have behind language are people. And it turns out there is an entire field of study that's dealing with people, which are the social sciences. So we do have a reasonably good understanding of people's values, behaviors, worldviews, and so forth. And so what's sort of the missing links are to connect computational linguistics and social sciences. Now, we are not really starting from scratch. There is a lot of work that has happened already, in particular in this direction of using computational linguistics to understand people. And for instance, there is a lot of work that looks at how we could replace surveys by doing, for instance, data mining on social media. But there is also this other direction, which I want to build more in this talk, on leveraging what we know about people to build better computational linguistic models. And so I want to walk you through 3 sub-projects, which primarily focus on this idea that if we know something about people, we can build better computational linguistic models, and basically move away from one size fits all. So one of the first projects that we worked on really tried to answer this question on whether words are used differently by different people. And the early motivation for this work is actually stemming from a theory that I find really intriguing and interesting. It's the Werf-Sapir theory, which really what it states is that people with different linguistic backgrounds would think differently. So this is also referred as linguistic relativism. And there is the Werf-Sapir theory goes back 50 plus years. But there is also recent work, primarily the one line of work that I follow quite closely is from Lera Boroditsky. And here is an example from her research where so she sits in a cognitive science lab and she runs studies in the way that psychologists would typically run them, where they would bring people in lab. So in this one study, she brought people in the lab who were in the first place German native speakers. And she asked a simple question: what do you think about the sun? And basically asked these German native speakers to talk about the sun. So you can think for yourself also, what do you think about the sun in terms of attributes? So she did that with a number of German speakers, and then she repeated the same experiment, but this time with Spanish native speakers from Mexico. And again, asked them, what do you think about the sun? Now, what she observed is that there was a cluster of descriptors that emerged from each of these groups. So the German speakers refer to the sun as being nice and warm, more commonly, whereas the Spanish speakers refer to the sun as being big and strong, again, more commonly. Now, I'm curious, and you can type in the chat if you want, if anyone can think of why is it there is this difference, or at least what's the hypothesis behind this work. Anyone? So the reason is the gender of words, which turns out to be different for the word sun. So it's feminine in German, it's masculine in Spanish. And this apparently led people to think about this, this celestial body in different ways. So the German speakers would use the more feminine descriptors, whereas the Spanish speakers would use the more masculine descriptors. Now, indeed, there is cultural differences. And in fact, in Lera Boroditsky's work and also Werf Safir hypothesis, it's going even deeper. So the claim is really that there is the language difference that leads to these distinctions that people would make. So the fact that the gender is different would make people to think of the sun in more feminine terms or more masculine terms. And I see now more answers coming in the chat. So it's indeed the gender. And the same experiment was repeated for a number of other words with the same kind of question, like what do you think about the bridge, for instance? Again, to German speakers, Spanish speakers. And this supported this hypothesis that people depending on the gender, people would think differently. Now, there is a number of other experiments that show how people from speaking different languages would speak differently, think differently about time or about directions and about colors. I think that's one of the more famous examples and so on. Now, I was really, like I said, I was really fascinated by this theory. It wasn't really very practical for us to apply in its original form. And so what we said, well, maybe we could do something about scaling it up. So rather than dealing with, say, 10, 15 words, which is what people in psychology would typically do, because it's very time consuming to bring people in the lab, ask them these questions. Maybe we could use just a language as it occurs online. But then there are challenges that come with separating language from culture, which in Lera Boroditsky's work is a clear distinction that's being made. So what we did, we said, well, let's scale this up and see if we identify such cultural differences in language, but we are not even going to do multiple languages, but rather do multiple cultures. So different countries speaking English. And I see there is a comment in chat that there could be a different experience of the sun, and the same would be for any other word that you would consider. There could be a different experience, and that's true. So, but I think because we relax this constraint of going after language, like thinking differences, but rather cultural differences, in a way, everything is fair game. So the fact that, say, the latitude of the sun is different, the country is different, and the perception of sun is different, that would all be fair game. So really what we are after is to see if we can identify words that are used in different ways by two groups of people. And this, with Pascal, she mentioned we were thinking about semantics a while back, semantic parsing. One of the problems that fascinated me for a long time was word sense disambiguation, where you take a word and then try to distinguish between its meanings. And in a way, this is really that same old word sense disambiguation problem, except that here it's word culture disambiguation. So the way we frame the problem is, given a word, and given this word in context as used by different people, can we tell who used the word? Was it somebody from group A or group B? And so with this framing, for one thing, we can use a lot of the work that has been done previously in word sense disambiguation. We can also scale up this problem of seeing whether people from different groups or different cultures would use a word in different ways. So this is the way we set it up. Given a word and given two groups, we want to identify first if there are usage differences. It's not a given that there are. There could be words for which there is no distinction, and that's fine, but we want to identify whether there are words with any distinction. And if we do find such words, then we can zoom in and try to understand why is it that there are such distinctions. So, like I said, one goal with this work was to scale it up compared to what's typically done in social sciences. So we picked 1,500 target words. And in the first experiment, we worked with people from Australia and US. And we had blogs. So we had about 300,000 blogs from Australia, about 450,000 blogs from US. We balanced over time so as that we don't have salient topics from just a certain period. And as I said, we really frame this as word sense disambiguation. So for a given word, we have a number of instances from each of the two countries. And we extract feature vectors. We run them through machine learning algorithm, and we want to see whether we can distinguish between them. So do we get performance that's higher than a random baseline? If we do, then we infer that there is some signal, there is something that's different about how these words are used that maybe we can identify through further analysis. So I mentioned that we find a lot of inspiration in all their work in word sense disambiguation. And so as done there, we look at local features. So it's word to the left and right of the target word. We looked at words that occur more frequently with the target word in a larger context. We look at social linguistic features, for instance, linguistic inquiry and word count, which would group words into categories such as positive, negative, I usage, using the word I, using the word we, and so forth, polarity, effect, and so on, and also some syntactic relations, whether a word modifies another word, whether a word is the subject or the object, and so forth. So with this in place, for the 1,500 words, on average, we are able to get 58%, which is significantly higher than the 50%. But I'm presenting this result only in passing because this is really not our goal. So it's not our goal to do as well as we can for all the words, but rather to have a mechanism to identify those words for which there is a significant difference. So if there is a word for which we can reliably tell who said that, in our case, was it an Australian or an American, then there might be something interesting about that word in the way that the two groups use that particular word. So here is an example. So the word travel, for which we could tell with nearly 70% who said that. So was it an Australian or an American? And I'm showing here two examples. So in the first one, discover a beautiful patchwork of fishing, farming, and forestry activities by traveling to the region. And the second one is showcase your nephritic attitude the next time you travel with this laptop bag, featuring a Gray's Anatomy illustration of a kidney's nephron. So question for you, who do you think said the first statement? Was it somebody from Australia or was it somebody from US? So if you could just quickly type in chat the first thing that comes to mind without analyzing the language too much. So US. Okay, so the first one is, in fact, Australia, and the second one is US. And this is just to illustrate that even for people, it's not necessarily a straightforward process to distinguish. Aside from this, there are other words for which we found clear distinctions. For instance, for nouns, it's source and style. Adjectives as are happy and hard. We also found verbs with clear distinctions or adverbs. Now, among the 1,500 words that we started with, we found that about 400 of them had such clear distinctions, with nearly 20% above the random baseline, which really says that there is something about that word and how it's being used. So in order to zoom in, we wanted to see whether there are different meanings that are more predominant for this word. Now for that, one way to go about it is to say, okay, I have a word like travel, for instance. I look up the dictionary, I assign the meaning that's being used in each instance, and then I see which meaning is more often used in Australia, which meaning is more often used in US. Now that's not really very practical because it's a lot of time that would go into just annotating the data. So instead, what we decided to do is to use topic modeling, which is a mechanism to do bottom-up discovery of topics, which in our case would be the meanings of the word. So we will first run this topic modeling on the data for one word, and then we can assign the topics that we find to each individual example in the data. So for instance, the example that you've seen earlier for the word travel, we'll get this assignment of topics. And this will allow us cumulatively to figure out which of these general themes that we identify in the data would be more predominant. And as an example, I want to show you a word that emerged from our data. So we didn't necessarily have a hypothesis to start with, but we discovered this word as having clear distinctions between how people in Australia use it versus how people in US would use it. And we see that we found there are 9 general meanings. And among them, in Australia, there are 2 meanings that are more dominant, would be meaning 3 and 9, and then 1 meaning that's more dominant in US. So here is a question for you. When you think of university, what are the words that come to mind? So what are some of the things that you typically associate with university? Now, Pascal is watching, so you better have the right answer. Cool, great sea view. That's a good one. Anyone else? So you think of school, library, education, maybe career, research, lab, class. So those are the things that would come to my mind as well. And it turns out that that's also what's predominant as a meaning in Australia. So when people would say university, they will generally be associated with this theme of students, research, teaching, and so forth. Now, this is not the topic in US. It turns out that in US, the dominant meaning is that of sports. So It's game, football, basketball. And when you think of it, it's actually true that there is a big culture of sports in universities in the United States. And the data that we have is really not coming from people like you and me. It's coming from lay people, so the people who write the blogs. And that is the general perception of university as a place for sports in US, unlike Australia, which has a different dominant meaning. So now with this finding that there are indeed clear distinction that we would see in terms of how people use words and how the kind of association that they will make with words. The next question that we ask is, can we build language representations that would account for these differences? And the task that we address here is, again, a core task in language processing, which is word association. The word association, you might have played this game as a child, maybe even as an adult, when you say a word and then you have to think of what is the first thing that comes to mind. So pretty typical example is when somebody says cat, and then you have to say, what is the first word that comes to mind? And most likely will be dog. I think that's the more typical cat-dog association. Lazy, okay, so that could be also a good one. Now, how about this one? So if I say sleep, what is the first word that comes to mind? Dream. So I see a number of responses: home, night, awake, bed. So it's interesting, if I see this correctly, that the same person suggested both dream and awake. And in fact, it turns out in a study going back many years, so about 100 years ago, 1910, there was a study that was done by two psychologists where they done exactly this exercise that we've done here. They would ask, here is a word, what is the first word that comes to mind? And sleep was one of the prompts. There are a number of other prompts. And what they found is that there are different associations depending on age group. And also, they also looked at gender. So for instance, for sleep, which is the word that I use, they found a dominant response of dream among the younger age group and dominant response of awake among the less young age group. And that's why I said it's interesting that it seems there is one person in the audience who's sort of both of them, dream and awake. Although I would count the first one, because really the exercise is what is the first word that comes to mind, so sort of your first immediate reaction. And similarly, they found for other words. For instance, food will have a dominant response for the younger group of eating, the less young of drinking. And so there are these neutral, emotionally neutral words, which apparently would generate a larger spectrum of responses where they found distinctions across age and across gender. Now, what we've done, we wanted to replicate this study and also bring it in digital format. I actually do have a copy of their study from 1910. It's in a big gray book sitting in my office, printed, because that's how the studies were done at that time. So what we've done, we took the 100 words from the Kent and Rosanov study. We also added about 200 additional words. And then we ran on Mechanical Turk and a study where we did what we've done here. We asked people, tell me the first word that comes to mind in response to this prompt. So we had a total of 300 words, and we ran them with two groups, one group from India and one from the United States. You may wonder why India. There is a large population of mechanical Turk workers, and the same is for US. So that was a major reason for this selection, aside from the fact that both countries would speak. There is a large population of English speakers. And we asked for 400 responses per task for each of the two countries. We had the word association questions. We had some spam check questions, and then we also have a demographic survey asking for gender, age, location, occupation, ethnicity, education, and income. So all in all, we ended up with more than 200,000 responses, which after removing spam, we had about 750 per word. We also did a subset of the data which was balanced over, we call them quarters, which would be balanced over gender, balanced over countries. And that led us, with this balancing, we have about 450 responses per word. And here is an example from the data. This time is the word bath. I will not ask you to type in chat, but you can think for yourself what is the first word that comes to mind when you say bath. And I'll tell you what is the dominant response for male respondents from US. So most of them said water. Then the dominant response for male respondents from India, again, is water. Now, when we ask female respondents in India, dominant response was soap. And then finally, dominant response for female respondents in US was bubble. So you see there is, I see Pascal laughing, and I had the same reaction. And again, there is a long tail, but this is what you would hear more commonly. And we found there are other words that have clear distinctions. For instance, when we have the prompt expect, for male respondents, most common would be nothing, for female would be baby. When we ask for course, for male would be goal, for female would be study. Admit, in India, the most common one is hospital. In US, it's admitting guilt. And then for comment, we see more of a social media versus more in person. So comment is say in US, Facebook in India. So the first thing that we've done with this data is to analyze the responses that we got. So we look at the average number of responses per word. And what we see is that there is more variation in India versus US. There isn't really a major distinction between male and female respondents. The other thing that we've done is to what extent people would agree more with their own group. So here what we've done is sort of a leave one out kind of strategy where we take one respondent out of the data and see how well their response agrees with the dominant response from other people in their same group. So say I compare an Indian person with other people from India. How well so that's the primary column that you see here. We also look at how well one individual that we take out of the data agrees with the top 10 responses from their own group. And that's what you will see in the top 10 column. And then also we look at cross groups. So really what is of interest here is to compare these two tables. So the one here with the one in the bottom. So what we see is really the hypothesis that we started with is that people would tend to agree more in their response with other people from the same group. So people in India would agree more with India, which is what you see here, as compared to say people in India with people from US. There is less agreement in what they would say. Now, the next thing that we've done is to really try to answer the question that I started for the second study is, can we build models that will more closely emulate these associations that people make? So as opposed to saying, I have one model and that's just the sort of the one size fits all for everyone, can we build some word association models that will more closely match what people from different groups would think about language or about these associations? So once again, we use block data, and we have this data coming from people in India, people from US, male and female, and I'm showing here some statistics. Again, it's balanced over time. So we have 7 years of data from 1999 to 2016. And we created word representations using a model that's pretty typically used which is neural networks to create word embeddings. I'm told the audience it's pretty broad, so just very briefly, the core idea in neural networks is that you will want to predict the context of a word based on a target word. So if I have a certain context, for instance, the cat sits on the mat, I want to see to what extent from the presence of the word cat, I can predict the other word, like the sit on the mat. Usually we have words to the left and words to the right. And with this simple idea that from one word, I want to predict the other words in the context, I can basically train some word representation. So I can train a neural network, which is what's represented here. And in the process, learn really what cat means. I will end up with the vector representations for that word cat. And conversely, I can also do the other way around, where I start with the context and I will predict the target word. So this is what is pretty typical in language representations. Nowadays, we have contextualized embeddings, and I'll say a bit more about that in the third study that I'll share. But here what we said, well, if we can build such representations for words using these neural networks trained on a large data, what if we add a label to the words? So instead of just saying this is the word oil, I would say this is the word oil as spoken by somebody from India, or this is the word oil as spoken by somebody from US. So I basically add a label that indicates who's behind this particular instance of the word. And that's sort of the only change. We retrain the whole system and we come up with some word representations. But now we have this demographic word representation. So I have a representation for the word oil in my example as used by somebody in India or as used by somebody in US. And there is a second variation that we have where we do the same also for the words in context. I mentioned previously that this particular model is trained by having as input a target word, and at the output I have words in the context, so to the left and right. So I could do the same thing. I say, well, I know something about my input word. It's said by this particular culture. I also know something about the context words. They are also stated by somebody from the same culture. So I add that label, again, to both target word and context words. So the outcome of this is a representation for a word as used by a certain group of people. So in order to see to what extent this works, we have the data that we created during the word association task that I described earlier, where we have a word as a prompt and then the dominant response by a certain group. And we can measure to what extent using a generic model, I can match the top choice, top 3 choices or top 10 choices done by either, in this case, I have gender, so male or female. So how well I can match with a generic model, which is what the first line is showing, versus using a model that is trained so that it accounts for who's behind the language. So if I count for the people behind the language when I actually build the model, so I basically build representations that are specific to these two groups, I can have a representation that's more accurate in terms of actually matching what the two groups will consider. Like when I have the human evaluations, the data that I collected on Mechanical Turk, it will be more closely matched by our demographic aware word representation as opposed to the generic ones. And we see a similar, although weaker trend for culture. We see in general that for data from India, so we'll get a better match with the demographic aware embeddings. So really what we learn in this study is that by making this relatively simple change in the models and really say we know what is the group behind the language that's used to train these models, we end up with word representations that are a better fit for those particular groups. Okay, and I have now just one more study, and also the most recent one, which is taking us one step further and trying to answer the question of what if we want to model more than one dimension. So far we looked at one dimension at a time. We said it's either culture or gender. But what if we want to look at multiple dimensions? And as a motivating example, here is language as used by two users. So say we have user A and user B, where they both use the word health. And it is in different contexts, but it's somehow related context. So the first one is say, doctors think this is bad for her health. The second one is saying it is usually bad for your health. So if we were to consider maybe some of the more recent contextualized word representations like bird, they would probably come up with very similar representations because the contexts are similar. Yet, if we would look at the nearest neighbors that we consider for these words in the context of each user, for the first user, the most similar words would be preventative, insurance, reform, medical, and education. Whereas for the second user, in their interpretation of the word health, the words that are more related would be professional, mental, conduct, experiences, and online. So this is what we would get if we were to have a user-centric word representation. Like this would be the most similar words to the word health for each of the two users. And in the generic interpretation, which is what we currently get with NLP, would be words like medical, preventative, insurance, safety, and healthcare. So what we are trying to do here is to create word representation that are specific to a user, so account for their view of the world, in which health has a certain meaning for one user and it has a slightly different meaning for another user. So the core idea here is that we can get these user-centric representations through some kind of user-centric language model. Now the question really is, how do we do that? Like, what do we know about the user? And there are at least two things that we could look at. One would be writing of that particular user. So we get a lot of data from that user and train a language model on that. So then we'll have these associations that would allow us to say, well, this particular user, when they talk about health, that's what they primarily think of. That has some issues which have to do with privacy. Many users may not be willing to share their data, or even if they share it online, may not be willing to have models train on the data. And then there is also the issue of data size. Many users may not have enough data, even if they are willing to share, to train a robust language representation. So we are ruling that out. And instead, what we consider in this work is another way of learning something about the user, which is through their attributes. So for instance, if we know something about the user, say they are a female from the United States, computer scientist, we can compose a representation for that user by taking what it means to be female, like a representation of words for the demographic group of female, for the demographic group of United States, and then computer scientists, and then we put them together and we'll get a representation that is, we hypothesize, is fairly close to what this user would mean, knowing their attributes. So what we have here as data, we switch this time to Reddit so that we can have a large number of users for which we know demographics. And we found demographics by doing some linguistic analysis and pattern extraction. So for instance, for age, we would have expressions such as I am blank years old, which would allow us to extract age. We have religion, gender, occupation, location. And so all in all, we ended up with 62,000 users from Reddit that have at least two demographics. And what we want to see here is to what extent we can build language representations which are working better for a user than a generic one-size-fits-all model, and yet are not necessarily trained on their data. So it's not trained on the user data, but rather it's done in a compositional way. So as I said earlier, we know something about the user. Maybe we know their age and gender and occupation, and we compose a representation based on what it means to be of that age, that gender, and that occupation. So the question is how to come up with these representations. We consider two different alternatives. One is when we create a general embedding for each of the attributes. So we have an embedding or a representation for what it means to be young. So we train a neural network the way I showed earlier, and we create a vector for what it means to be young, for what it means to be old, for what it means to be from UK, US, and so forth. And then we merge that with the representation for the word, which is, again, what I showed earlier as a word embedding or word vector. The alternative to that is to create separate word representations for each of the attributes. So this is work that was first introduced some years back by Bauman and colleagues in the context of locations. And we are inspired by this work to create different word representations for different demographics. So we have, in the context of a neural network representation, we have separate weight matrices, which really result in separate representation for a certain word as spoken by young people, or the same word as spoken by older people, the same word as spoken by somebody from UK, and so on. So we have all these different flavors of meanings for one word, which correspond to different demographics. And those, then we can put them back together and create these representations for individual words without really having access to any of their data. So the way we'll check on whether this works well is through what we'll typically do through language modeling evaluations. So we have some held out data, so some data from a user, and we want to predict their language. And what we could do is to use a one-size-fits-all model, which is a generic model trained on the entire data, and we try to predict the words said by a certain user. And this is what you see under baseline. Or we could do what I suggested earlier, where we have these different representations for different groups and different words, which we then compose. And this is what we get here. And for those of you who are not familiar with Perplexity, this is a metric that's used to measure the quality of a language model in the setting that I just explained. And the lower the perplexity, the better. So it's really to what extent I can predict a word in a held out test set. And it turns out that if I have these demographic aware word representations, I can do those predictions better because I get this lower perplexity. So core message from here is that it actually helps to acknowledge who's behind the language. When we build these models, we can build more accurate models this way. We also did a split, and I'm getting closer to the end of the talk, so we can open it up for questions. We split by gender to see to what extent the different genders benefit from this way of looking at word representations. And we see that female language to start with had lower perplexity, which I think is interesting in itself. And what the orange columns show is how well we do in terms of predicting language from each of these two groups, male, female, or unknown gender, so people who haven't reported, when we use the demographic word representation. So in all cases, we see a decrease in perplexity, which means a better result. We see the same for age, so consistent improvement across the different age groups. We see the same for location, with the exception of Asia. So there we didn't really see an improvement. And you probably wonder why we have these groupings. It really had to do with representation in the data. So Reddit is very frequently used by certain groups of people for which we had broader representation. So UK, for instance, is widely represented, Canada and US, but less would be Europe, Asia, Oceania is another example. For religion, we see the same thing. It's interesting that those who do not report any kind of religion had the best improvement. That's something that we stumbled upon and thought about it. We didn't necessarily come up with a good reason as to why that happens, but that seems to be like lack of religion seems to be a special group. And it's not really atheists. So they are the people who declare themselves to be atheists. But there is another group which is fairly large, which just doesn't talk about religion, for which we saw a significant improvement by accounting that they are behind the language, creating representations that are specific to them. We had one of the largest improvements. So we also had evaluations on the data that I described earlier. The one where you ask for a prompt like sleep, what is the first word that comes to mind, where we had data from these two countries, India and US. And we see significant improvements with the compositional word embeddings that I just described compared with the previous word. Now, one disclaimer here is that we have a different data set. And so we do have more data now than we used in the previous experiment. So there is an effect of that as well. We also see that for gender, again, significant improvement across the board by using these compositional word embeddings compared to the previous work, and age as well. We didn't really do that in the previous study, so that's why we only show the results that we get for age here. So I do not want to conclude without bringing up ethical considerations and limitations. We observe these associations between language and demographics, and we've been exploring ways to build natural language processing, or more specifically, really language representations that account for the people behind the language. But it is really just correlation. So we observe these correlations between language and demographics, doesn't mean causation. There are significant limitations that have to do with data distribution and coverage. We do not have coverage for all gender identities, for all locations, religions, occupations. That's a shortcoming in the data itself. Social media is not uniformly distributed, and that's the kind of data that we currently have. And in general, even for the identities that we have representing the data, the distributions are skewed. So for instance, on Reddit, there is a dominant participation from young male atheist people. But in general, I do very much believe that we have to more carefully start thinking about data disaggregation, which is really critical for building more equitable models. So if we say we have these one-size-fits-all models, they are supposed to be good for everyone because it's not really taking sides for everyone. It actually turns out that they are good for the majority. So they work well for the people who are the majority being represented in the data, but they do not work well for the minorities. And in fact, as soon as we start to disaggregate, so for instance, the kind of splits that I showed here, say male, female, different countries, if we take, say, African Americans, Hispanics in data across US, we'll start seeing that the performance that we have is actually not representative for everyone. We have models that work well for the majority, but they do not work well for minorities. And so I very much believe that data disaggregation is critical. And there is one book which I keep recommending to everyone who wants to learn more about how important data disaggregation is Invisible Women. There is only very little about NLP, but in general, for pretty much anything that has to do with data, without disaggregating, we really are blind to the shortcomings in the data and models that we have. And NLP is case in point. By having just one-size-fits-all models, we are blind to the kind of shortcomings that we have in our models. So I will conclude and encourage you to think more about this connection between language and people. I think there is a lot that can be done in this space. And the final message that I want to send across is that really language is not only about words, it is also about people. And the data sets that I mentioned are publicly available. So if you are curious, you can check them out. And with that, thank you for your attention, and I'm happy to answer questions.
Thank you, Professor Mihalcea, Rada, really. Thank you, Rada. What an interesting talk. It was mesmerizing. Very, very unique and very interesting. As usual, Rada always has this unique visions about what we should do as a field. So let's open this for Q&A. People can ask questions in the either in the QA session, or you can just ask questions in chat. You don't need to raise your hand. So we can open this for questions now. Let me see. You can use chat or QA. I have a lot of questions, but I still want to wait for others to ask questions first. Actually, why don't I ask my question now? So Rada, it's kind of counterintuitive at the end when you said that. I kind of understand what you say, you know, if we have one size fits all, and then it's going to be, you know, the characteristic of the majority group would just overwhelm the individuals. But are we not worried that if we divide these people into demographic groups, then we are, how do I say this? But should we actually segregate people into these demographic groups, or we actually have to do really, really personalized? Meaning that, for example, I can think of applications of language models, right? We use them to generate text. And today's language models, when you use them for generation, it generates very sexist and racist kind of biased results. Now, if we divide this into demographic groups, I can imagine that if it knows that I am a woman, it would generate something different. But then perhaps I am not a typical woman. You know, how do you resolve these issues? People actually will perceive that. Wouldn't they perceive it to be more, you know, by definition, more discriminative? Because by definition, it is more discriminative. And I understand the merit of it, but I just wonder, is there any pitfall?
Well, there are pitfalls. Like one is privacy, for instance. So the closer you get to like truly personalized models, like if a model would tell me things that maybe I'm not sharing with too many people, I would be surprised, and maybe I wouldn't want, not even from a system, to start telling me things that I'm not very openly sharing with others. So when it gets very personalized, I think there is the danger of privacy violation. So that's one thing. Another, you say, and what I'm suggesting here is that you can maybe get around that by doing these compositional models. So I'm not really creating, say, models for you as Pascal, but maybe I would take some things that may be representative for you in whichever way you would want to portray yourself as sort of attribute, and then I compose something. So it's not really using your data, being like very personalized, but still it's better than a generic model. The other thing, which is something that we are exploring now, so what I talked about here is when you have attributes, and these are really labels, which we may or may not agree with. The other thing that we are exploring is finding users that are similar to me. So maybe by some metric of similarity, I find this 100 users or 1,000 users that are more similar to me. And then I can compose something based on those users. Now, when it comes to generation, I think there are yet another set of issues is the echo chambers, right? So if I keep hearing whatever I say, then am I learning anything? And we see a lot of that on social media, right? So with this attempt to personalize, we just keep hearing what we are saying in a way, like in an echo. So that's another set of problems. What I'm really saying here is having ways that are maybe, and I don't have the right solution necessarily, but at least moving in what I hope it will be the right direction, to not have models that only do justice to the majority. So there are models that would also account, okay, here is a person from my example, like the city of Detroit. So account for whatever their values are or beliefs or way of using language and so forth, as opposed to forcing them into this can, which is what NLP currently does, which is representative for just certain demographics. So there are different issues, then pitfalls, as you call them. And I think if every single application will have its own that we'll have to think about.
Yeah, I can imagine though, like we work on conversational AI and we work on systems for the elderly. And I can imagine that if we can train models that based on more like taking into consideration the demographics of people's experiences, then a conversational AI system will certainly work better with targeted groups because they are targeting demographic groups. So there's a question in the Q&A by someone asking, thank you, Professor. Thank you for your presentation. May I ask one question? Is there word association differences and sentiment differences for news report from different countries, for example, BBC and CNN?
The word association in my mind or our mind, so in the way we'll be exploring, I think to me, it's very close to what we think about the world. So that's one thing, and that's what we've been doing here. And we found that there are differences among people from different countries. Now, when it comes to sentiment, maybe what you are suggesting, and is for different news, there is different sentiment. I think there is another layer in language analysis, which is very interesting. It's really how, say, the same piece of news, the same event is perceived by different groups. And there is some work that has been done, not a whole lot from what I know. And I think it's a very interesting area of exploration to see how the same event, including, for instance, now the pandemic. So how are different people from different countries with different cultures and beliefs and so forth react to the same situation? And we haven't really done much in my group, but I think it's an interesting area to explore.
Yeah. So there's another question. Thanks for the interesting talk. How can we recognize all these important user features?
Well, I think it's a good question. We've done the more sort of the traditional path where we put features in, like feature engineering, and then we see whether they make a difference, but these are hypotheses that we started with. I think one could do also more flexible approach, like topic modeling, for instance, to have more like sort of data-induced features. It's really whatever intuition you would have. I don't necessarily have a good solution. You can find what features are important by doing feature ablations, feature analysis. Now, whether we accounted for all the features, I don't know. So it's really based on our intuition that context would matter, some social features would matter, but there might be others which we haven't really captured because we haven't even considered them in the first place.
All right. Okay, there's another one. Oh, there are two in the chat. I see. Hi, Professor Rada. Thank you for presenting. I have one question about the personalized model. How much data does it need for training such a model?
So you don't need a ton of data because, like I said, we don't really do personalized to the user. Rather, we do entire groups. And so for entire groups, first, it's relatively easier to find data for an entire group. And then you don't even, like, depending on the model, like in one model, for instance, we sort of retrain it from scratch. And so you will need reasonably amount of data so that you can actually sustain an entire neural network. But then there is also other ways in which you could do sort of fine tuning on a group. So you start with the generic model and then you fine tune it on that particular group. And in that case, you'll probably need a bit less. I shared, and I'm happy to share more in terms of actual numbers. So in our case, we actually use relatively large data sets, but I don't think you need that much data to train. And like I said, there is the benefit of doing it for an entire group at a time as opposed to individuals. So in principle, there should be enough data.
Okay, next question, Rada Pascal. I wonder if it's possible to automatically cluster unlabeled text into demographic groups so that the demographic embeddings could be applied to large data. The model size of a large, huge language model might be reduced. Automatically cluster unlabeled text into demographic groups so that it...
You could. So there is, you could cluster. So for instance, if you were to take English, I would imagine if you put English as spoken, I don't know, by people in US, UK, and if you do some clustering, maybe there will be some separation that would acknowledge for those. There are also other distinctions between users, which probably a clustering way of separating data would identify. Like in our case, we had these widely acknowledged attributes like gender or culture, like country, religion, and so forth. But with clustering, I think you will have more flexibility. So that could be something to try, where you have a set of users, you do some clustering, and then you work with the clusters as your groups. And I mentioned briefly that we have some ongoing work that is sort of going that direction of not using existing attributes, but really working with a pool of users, doing some clustering, and then trying to affiliate a target user with one of these clusters. The downside is that there is no labeling. So I wouldn't say, well, it could be downside or upside. I'm not really saying for a given user, like I'm composing from, say, female US computer science, but rather I will do a composition from the closest clusters, which may be unlabeled. So interpretability may suffer, but it would be a sensible approach to consider.
Another question. Thank you for the talk. Surprised that we can also discover the gender difference in language usage in English, which is less gender compared to, for example, spoken Japanese. Are you planning to expand your work into another language?
So we've looked a little bit, like speaking of other languages, we looked at Spanish, which also has, so we've been doing somehow greedily looking at languages that have multiple cultures represented. Like English, for instance, is spoken in multiple countries. And so that would be like multiple cultural flavors, but with the same language. So we don't have to do machine translation. Spanish is another language like that, where you would have these different cultures being represented with just one language. As for the gender differences in English, it turns out there are markers that we as humans don't even observe, which are in fact associated with gender. Like one, for instance, that was found in other work, is not our work, that the word off is more often used by male writers, which is interesting and non-intuitive. Why would that be? But it turns out that computers, because they are not that smart, they will just count words and they will rely on this kind of association. So in fact, finding gender differences in a language like English is not necessarily hard. There are markers of gender in the language, even though we don't observe them as humans.
Thank you for your talk. It seems that your work goes in the opposite direction of debiasing. Yours tries to make models more personalized. Debiasing makes them more general. In what case would you use each one of them?
So debiasing, the work that I know in debiasing is trying to stay with the sort of the one size fits all and fix it. right? So there is bias in the models and try to fix that. So it keeps a general model, but then fixes the issues. What we're doing is saying, well, there is value in data disaggregation. There is value in acknowledging that there are different people behind the language. So it's, in fact, as the person asking the question notice, it's a different direction. So we say, let's move away from one size fits all and create these more personalized representations. I think to the extent that debiasing works, you would say that's probably a more general way of approaching things. But debiasing doesn't necessarily, so there is different directions in debiasing. There is one that tries to debias the language itself in the sense of not making, say, what was that example from a paper title? The computer, I forgot the example. There's a computer programmer and housewife and something else. So there is bias in the association that we see, which doesn't necessarily have, so it's really the language itself, which doesn't necessarily have to do with the people behind the language. And then there is also having worldviews, which may or may not be biased, which are representative for certain groups, which the debiasing work will not address. So keeping the one size fits all would keep the one dominant view of the world represented in language, which may not be representative for the minorities, even after debiasing is done, may not necessarily address what I see as potential issues with not accounting for people behind the language.
Thank you. There's another question. In one slide, why is it that the differences for Asian groups are not significant compared to other groups?
To be honest, I don't know. So we'll have to zoom in deeper and see why is it that for the Asian group, we didn't really see improvement with the demographic aware language model.
Another question. Thank you for the presentation. I'm worried the personalized model might aggravate the stereotype. How to solve this problem?
So stereotypes, I'm not sure that they would aggregate. Well, I think the one thing that I worry about, for instance, is what I mentioned earlier, the sort of the echo chambers. So getting into these small bubbles and not necessarily being aware of the outside world. So even just by being exposed to language by other groups, we have a more general, like there is some more real worldview. Stereotyping, I'm actually not sure. I like in other work that we've done, and speaking of what Pascal mentioned earlier with the language of the elderly, we've seen that in fact stereotyping happens more across groups. Like, for instance, elderly people and younger people, the elderly see themselves very different than how the younger people see the elderly. And so stereotyping really happens across groups more so than within a group. And so that's not something necessarily that I would worry about, more so than those like bubbles or echo chambers. So doing too much personalization may be damaging in that sense. So we'll have to carefully think, in particular when it comes to generation or recommendations. So.
All right, another question. Thank you for the interesting talk, Professor. I have one question. How will language models react to the increase of demographic dimensions from 1 to larger numbers?
And that's a very good question. As it's indeed the case that now we currently have a certain set of demographics represented, say, for instance, for locations, as we have more and more countries being represented digitally. I think it's a very good question. How to deal with a large number of demographics and how to deal with different granularities, right? So we say, okay, what do we consider as location? We take, I don't know. I said Asia, it was pretty broad, so it's the representation that we have, but presumably you'd want to go maybe at country level within Asia, and maybe even at city level, or even beyond that. So for higher granularity, it will be a challenge. Presumably, we'll also have more data for each of these demographics, so maybe it's doable, but it's something to consider, which currently I don't have a very good answer for that.
Yeah, interesting question. Another one, I was wondering about your thought of building a single model for all, but is capable of personalizing. Have you discovered or thought of any method to build such a model instead of training as one model for a specific demographic group, like multiple models?
So if you have one model, the one thing that we've considered, I haven't really talked about it here, but it's one of the comparisons that we make. You can take one generic model and then fine-tune it on a user data. And that's a reasonable approach. It does better than using the generic model by itself. Does, however, assume that you would have enough data from a user so you can do that fine-tuning. So if that's the case, then that's something that works. And it will still assume this one large good model and then do some fine-tuning for different users. There is a downside of first requiring enough data from a user and then second, the user privacy. So the compositional approach that we've been taking would address both of those downsides.
Another question. Thank you for your impressive talk, Professor. May I ask, is it possible to study a narrower topic than a language culture, such as a community, some specific roles in the society, personalization? What are the differences? I guess at the granularity of demographics.
I noticed already in what I talked about here as well, that different demographic dimensions, we see different differences. Like for instance, gender, we see a certain distinction between different genders as compared to, say, locations. I think it's interesting to consider in a paper that we currently have under review, we also consider professional communities. Like I have this belief that computer scientists think differently than other people, and the same would go for maybe people who are trained into philosophy would have a different way of thinking about the world. And so even like professional communities would be another split. And ultimately you could think, and there was an earlier question about clustering. So you could even go with the approach of not even naming this distinction, just do some clustering and find groups of people that have some affinity with one another, whether it's because of location or professional community, and build those language models for those communities. And so, yes, it should work for different groups. The question is, how do you want to define those groups? Whether you want to have a lot of interpretability around them. So you want to start with things that are already assumed to be known as groups, or are fine with more flexibility. And what we've done, we found sort of different differences again for the different groups. And it's interesting just in itself to see how these different groups would use words differently, zooming in on one word at a time. I could spend a lot of time just looking at data and seeing how, like the example I gave with the word university, that Australia and US would think differently about those. And there are lots of such examples that emerge when you start doing this analysis.
Another question, do you think it would be possible to make a model that can, I guess, you can guess the writer's native language or culture by looking at the blogs and comments in English? So you guess the demographics from their writing.
You could, and there has been some work that was done before along those lines of native language attribution. And I know, for instance, ETS has been doing that to figure out the native language of test takers. So ETS is this institution in US that will test for English. Some of you may be familiar with that.
TOEFL.
And so just based on yes, TOEFL indeed. Just based on the language, they can make a guess as to the native language of the, just based on writing in English, you can make a guess as to the native language of the writer. On one side, you could see this as an issue because it's privacy invading. Maybe somebody doesn't want to share their original language. On the other side, and the reason my recollection of why ETS, for instance, has done it, is that you can then personalize help. So for instance, if you want to assist with English learning, then you can have more personalized English instruction for that particular group.
That's very interesting. To what extent should we go fine-grained manner to avoid building too generic model? The balance between performance and personalization. I guess that's an experimental question, no?
It is experimental, and it's also a trade-off of
data.
I would say, so that's another argument, which I will not go too much into. I have an issue with the emphasis that we currently have on performance. So it could be, for instance, that we will lose in performance, but not doing the generic model. It's not what we observe here. But I think in general, if you build models, for instance, that are more equitable or maybe more cost effective, or I don't know, maybe address other problems, like would work better for minorities. Those are other aspects to consider. I'm not ready to make those evaluations, but for instance, for a choice like this, should we go with a general model or should we go with a model that's specialized for different groups? Aside for the performance itself, we should also make these other considerations. And it's not very straightforward to answer. It's a very good question. I don't have a short answer because it really depends not only on the performance of the model itself, but also what problems are you really solving? Like say if we serve as a minority and now we serve them better than we used to, it's a good trade-off. So keeping all those in mind when making those choices, I think it's important.
Have you thought about letting the model discover groups instead of predefining these groups?
Yeah, and there's the question that was, I think somebody else asked about clustering, and that's something that we have as ongoing work to discover groups, so doing clustering over groups, and then try to associate a given user with one of these discovered groups in order to create these more personalized models.
There's a question about transfer learning, another one about federated learning from the same audience member. Do you explore transfer learning between demographic groups? I think if you have a general model and you fine tune to each, you're by definition doing transfer learning. In NLP, we have, sorry, I'm answering the question for you. But
yes, please go ahead.
In NLP, we've done so-called transfer learning for decades. And in speech as well, we call them adaptive learning or adaptation or, Rada, give your thoughts on this question.
No, I agree with that. So in a way, this transfer learning, even like having the general or generic model, it's already in a way doing transfer learning because it can be applied.
Right. When we used to use Ngram language models, we will use domain adaptation, speaker adaptation, user adaptation. That's all transfer learning. And
in a way, we have been doing this even without realizing. Like one big surprise that we had about 2 years ago, like some of you who've been working, like Pascal, of course, and some of the other people in the audience may be familiar with Penn Tree Bank. Yeah. Right? So it's sort of good old Penn Tree Bank. We've been using it in NLP for 25 years. We train part-of-speech taggers and parsers and all that. So we had the curiosity in my group to look who's behind the language of Penn Tree Bank. And guess what? It's 75% plus, it's male authors. So in a way, even without realizing, we've been doing transfer learning because we've been training on this data, which is authored by a male demographic and applying it on female writings, like whenever we've done parsing or part-of-speech tagging or some of the other work that is built on Penn Tree Bank. So that's been happening even without us knowing that we do it. But there's also the explicit work that Pascal referred to, that we've been doing transfer learning for a while. And whether with a generic model, or we could consider, and I think it's interesting in itself for exploration to see to what extent you can go across demographic groups and how transferable that is. Like, are there certain groups that are more sensitive to the transfer?
Yeah. Well, the time is up, but I guess the other question from the same audience member is the lack of users' privacy concerns. We could explore federated learning to alleviate this issue. So it would be a strong training signal for personal language model. What do you think? Do you see the question, Rada?
I see the question, but I'm not sure how to interpret it.
Yeah, I think we can think about it.
We can think about it, yes.
I think it's a general federated learning paradigm, right? For anything like this, want to do personalized language model, you can,
Yeah, and
it's orthogonal to the issue we talked about today.
And in general, I think there are pros and cons for personal language models.
Right. All right, so our time is up for today, and it's also late for you, Rada. Thank you for staying with us to answer so many questions, and thank you for thank you for a very fascinating talk. Gave us a lot of a lot of food for thought.
Well, thank you very much. A lot of really good questions. Yeah. I'm excited to see that it spoke to you and you've been thinking about it. So it's a lot of really good questions. I have a lot of food for thought myself too.
Yeah, it's very thought-provoking. So thank you so much, Rada, and good night to you, and have a nice day to the rest of the students and audience members. Thank you.
Have a good day. Thank you. Bye-bye.
Bye.